This is Learning Assessment Problem 915. The problem-solving strategy here is the application of the power factor in calculating power in AC circuits. We're given some information about this industrial load which consumes 100 kilowatts of power at a 0.707 power factor lagging. The lagging nature indicates that the load has primarily inductive component, and the current will lag the voltage with respect to the phasors associated with that load. We are told that the load voltage is 480 volts at an angle of 0 degrees, and then the transmission line resistance is an important feature here, and that resistance is 1/10 of an ohm. We are going to calculate the power consumed in the transmission line by the current flowing to the load. Then we'll change the power factor to 0.94 lagging and compare the savings in power lost in the transmission line. First, we'll draw an equivalent circuit for this problem so that we can see where the various voltages and circuit elements are contained. So this circuit contains the power company on the left and our load for this industrial application on the right-hand side. The series resistance of the power line is indicated by R sub line, and R sub L and JX sub L are the components of the load at the moment. We have a load voltage of 480 volts at an angle of 0 degrees. Of course, the line voltage at the sending end will be something greater than that because of the loss of voltage across that series resistance of the line. So first we'll calculate the line current. I line is equal to the power in the load divided by the product of the power factor and the load voltage. And this is equal to 294.67 amps. And notice that all the units here are in root mean square values. So this is the initial line current. Now we'll calculate the power lost in the series resistance of the line. This is the square of the line current times the line resistance, and this is 8,683 watts. Now we'll change the power factor to 0.94 lagging. This might be accomplished by placing a capacitor across the load, JXC, and that will tend to reduce some of the inductive component of the load, reducing the overall susceptance and thus reducing the line current. So with the power factor equal to 0.94 lagging, we have that the line current now, I line primed, is equal to 221.63 amps RMS. So this is the line current obtained when the power factor is increased from 0.707 to 0.94. Notice that this is smaller than the initial line current of 294.67 amperes. Now we can calculate the power lost or dissipated in the line resistance with this new line current, and this is equal to 4,712 watts. So the saving achieved in reducing the loss in the power line is 3,771 watts.